Okay, so here we are with Unit 9, Lesson 2, and we just went over, started to go over the properties of acids and bases, and I just want to continue with acids and bases here. This is a continuation of the acids. Um, so if you look at here, and this is something you're going to see with bases too, acids and bases, or acids cause acid-base indicators to change. An indicator is something that tells you whether something is an acid or a base. It doesn't tell you anything about the strength. It just tells you whether it's an acid or a base depending on the color change. And you should be very familiar with these here to identify whether it's an acid or a base. So in an acid, if you take a piece of litmus paper and put it in, it will turn red. Phenolphthalein will turn from pink to colorless. So phenolphthalein is colorless in an acid. So don't get confused here. Phenolphthalein is colorless in an acid. What about pH? pH is a number that tells you whether something's an acid or base, but it also gives you a general idea about the strength. Acids have, and you know the pH scale goes from 0 to 14. Anything less than 7 would be acids. Okay, and the strength of acids actually, as you go from 7 to 0, the strength of acids increases as you go towards, sorry, I don't know why it keeps doing that. So again, when you go from here to here, one more time, as you go from left to right, the strength of an acid increases. So an acid that has a pH of, let's say, 6 is a relatively weak acid, right? I'm going to put weak here, and I'm going to put strong here, and there really is no cutoff point. Oh my goodness. There really is no cutoff point. So these are weak acids, these are strong acids. Bases are the exact opposite. Now, what about, what do all acids have in common when it comes to formula? Well, all acids have the general formula HA or HX. H is, of course, the element hydrogen, and A is generally going to be a non-metal. Okay, so, and X would be the same thing. So, for example, you know, HCl, HF would be another acid, but you can also have acids that have more than 2 elements that are ternary acids, like HNO3. Okay, those are all examples of acids. Notice that they all have H first, and we're going to talk about later on. It seems to be that all compounds with H in it are acids, and that's not the case. So let's go on to bases. In many ways, bases are the exact opposite of acids. And you can see here again, Table L gives us the list of the names and formulas of the most common bases, so we don't need to memorize this, you know, the names, how to name them. These are the most, this is a strong acid base, these are weak here. Dilute bases have a bitter taste. So, for example, antacids are bitter because they are trying to neutralize an acid. So you neutralize an acid with a base. They are slippery or soapy feeling. Like acids, they can also burn your skin and eat holes in your clothing. They are also electrolytes because bases are in essence ionic because a base always contains a metal and an OH. They do break into ions that would break up into an Na plus and an OH ion. So because it breaks apart, it dissociates into ions, it would conduct electricity. Weak bases are poor conductors, so this would be a weak base. So it would be a poor conductor. It would conduct, but not very well. NaOH is a strong base, so it definitely would conduct, and it would be a very good conductor. Now, when you're looking at bases, when it comes to neutralization reactions, we already talked about this with acids. When you take an acid and react it with a base, it's a double replacement reaction. It's called a neutralization reaction. And again, the H and the Ca switch. So now the Ca will join with the Br. Okay, once again, I got to figure out why that's doing that. Okay. So what would happen is the Ca would join with the Br. Now notice there's a 2 here, not because bromine's a Brinkerloff, which it is. That doesn't apply when it's in a compound, but because calcium is a +2, bromines are -1, so you need 2 bromines to cancel that out. But again, you form water, HOH or H2O. Bases also cause indicators to change color. Litmus turns blue in a base, and phenolphthalein is pink in a base. Not to confuse it with the colorless, is just kind of throwing people off here. Let's move down. Let's complete the properties of bases. Generally speaking, bases have a pH above 7. This would be a weak base. These would be strong. And strength with bases is the opposite. It increases as you get towards 14. So a base with a pH of 8 is very weak compared to a base with a pH of 14. And generally speaking, bases always have X, which means it's a cation, which means it's a positive, and an OH. So NaOH is a base, CaOH2. Basically, any metal that you put here for X, for most part, with an OH would be considered to be a base. And that is it for lesson number 2.